And if you click on the background information, this is the experiment that itself, as found in your lab manual. The first part is always the experiment itself based on the lab manual. Okay, so I just took pages since I'm the author, create a PDF file, and that's where it is. That way you don't have to keep referring to the lab manual. This is the data that you guys are going to be using for this activity. Okay, so if you click on that, this is the data. It's actually an Excel spreadsheet that I converted to a PDF file. The first part is the intermolecular force. If you scroll down, the second part is the pH of acids and base. And the third part is the absorbance of the cobalt chloride experiment. So part 1, part 2, part 3, that's the data. You find it on this tab right here. The PowerPoint is what I'm going to show you shortly. And then the video is actually me doing the experiment. Okay, so let me change and go back. I'll come back to that PowerPoint. I want to show you under activity 4, you'll see that it's broken down to intermolecular forces of alcohol. That's the 21st. And then the 28th, which is continue with activity 4. That date is incorrect because this should be next week, Wednesday. That's an incorrect date. So we've already looked at the background. Let's take a look at this right here. Because what I just introduced on this page right here, this is just the worksheet and the data sheet, but right here is guidelines on how to write your intro and the procedures. Okay, and even though this is not an experiment, we can treat it like an experiment. Okay, and remember that because we're not using lab archives, you guys are going to enter your intro and procedure in Canvas. You're going to enter your data and observation in Canvas, and you're going to enter your post-lab write-up in Canvas. But what I want to do is, based on the grading criteria that I use for this class, I want to guide you as to what you should include in this particular activity, which we are treating as an experiment. This is not a lot of points, but I want to make sure that you guys understand what should be included in a regular experiment. So here is a guideline for 4A. This is the intermolecular forces of alcohol, the date and the course number, and the title of the experiment. Okay, and then you don't have to put boxes. I just put boxes here to show you the different sections. This whole section is the intro and procedure. Under objective in 50 words or less, write the objective of this experiment, write what is to be investigated, the chemicals to be studied, and the experimental techniques to be used. If you can write that, then it tells the audience right away what's involved in this particular experiment. The background information should give you enough information to bring the readers up to speed. So look up the concept of intermolecular force and define it here, because that's the key in this particular experiment. You're determining the intermolecular force strength of these alcohol. So you need to define it. Otherwise, a reader who doesn't know what IMF stands for, they're going to be lost. Discuss how properties of matter is manifested through the intermolecular forces. How are boiling points and heats of vaporization especially, because that's actually what we are looking at in this lab, relates to intermolecular force. Describe why one chemical might have a stronger intermolecular force versus another, especially based on its structural properties. So this is what I want in terms of the background. You're bringing up the reader to speed in terms of the theories that are involved in this experiment. Write about the probes to be used. The probes are just the instruments that we are using in this particular experiment. For example, you guys are going to be using the stainless steel temperature probe. And how is it used in this experiment? What is the difference between Vernier and Logger probe? Because that's the program and the hardware that you guys are using. So since this is the first time that it's being used, you need to make sure that you explain it to your audience. Discuss how does temperature drop reflect on rates of evaporation? How does the temperature change, or the drop in the temperature as something evaporates, relate to intermolecular force? Elaborate how rates of evaporation infers the strength of intermolecular force. Discuss what type of intermolecular force are available to alcohol. Now we are specific to the chemical, and um, predict which chemical among the series, methanol, ethanol, propanol, and butanol. Although we're just working with methanol and ethanol, propanol and butanol are extrapolated based on the data. So you should also mention that. We'll have which will have the strongest and which will have the weakest intermolecular force, and write the structure, Lewis structure, molar mass, and type of intermolecular force available for these chemicals. If you look at the worksheet, show you the worksheet, that's the data table that I asked you to complete right here. Okay, so you should mention it in your discussion. Now, I know it's overkill for a simple activity, but I want to set the stage so that you understand that when it comes to your experiment, that's the level of thoroughness that I want. Okay, I want to make sure that we're all on the same page as far as what type of details I'm looking for. For this, and then after giving the background, then you do the procedure. For this experiment, write an outline of each step. Remember I told you when we were talking about notebook that I don't really want words, I want more pictorial diagram. But for this particular experiment, since it's the first one, I want you to draw an outline and then draw an icon representing that particular sentence in the icon. That will basically train you to do a pictorial flowchart. For example, one of the steps is to wrap a piece of filter paper that's cut out in 2 by 5 centimeters around the thermistor. This temperature probe is also called a thermistor, and then secure by a rubber band. Okay, show how vernier is set up and the settings, and then this is the data table that's going to be put in. In terms of safety, this all the chemicals that will be used. The methanol and ethanols are going to be listed, are the main chemicals in this experiment. I forgot to put in here how they are to be handled. In this particular case, you place them in a test tube and you close them with a rubber stopper so it doesn't evaporate. Okay, you never handle it by hand. And then go to this page right here to find the SDS data for the 2 chemicals that you are using. And I just want a screenshot of the first page. The first page pretty much tells me everything I need to know about this chemical, and then I just paste it here. Do the same for ethanol. And then the last part is answer any pre-lab questions, if any. So that would be what you would write for the introduction of your experiment. Okay, now I haven't had time to do this yet, but the next thing I'm going to do is I'm going to give you a guideline of what to include in your data and observation. And then I'll also write up a guideline of what to write up in your post-lab write-up. Okay, and again, rather than you guys guessing what you think I want in there, I'm telling you what I want in there so that there's no second guessing. And if you do that, then I will wean you off these guidance eventually. And you guys can give me a very good write-up that will prepare you for organic chemistry. But I wanted to show you this because I want to give you the fundamental information that you will need so that there's no second guessing what I want in the write-up. Okay, so that's that. We're going to get to this in more details next week. Let me go back to module. Okay, and then the last thing I'm going to do is show you the video of this experiment. And I want to make some editorial comments, and then we're done. Okay. The only thing that's due is this Friday. That's the until date for activity 3. Of course, if you can do it tonight, then you get a bonus points. if you can complete it by tonight. So let me go back to activity number 4 under background information. Okay, under background information, you see this video. I'm just going to click on that. It's going to show you the video. I want a full screen video, so I'm just going to click on that, and then I'm going to start it up. At this point, you guys should see the full screen of this video, and then I'm just going to basically go through this. Read this introduction, because this is my PowerPoint. This one especially, because it pretty much tells the heart of what this experiment's about. You want to include this in your background information. These are the equipments that you guys are using: the computer, the temperature probe, and test tubes. This is what it will look like when you set it up if you were in lab. Okay, so here's me in fast, because I don't want you to just like sit there while I do this 3 or 4 times, because it was very difficult to put the filter paper on with that small rubber band, with that rubber gloves. Anyway, here it is. What I'm doing now is I turn on the instrument and I let it run so that it equilibrates at room temperature. Then I just took, let me go back. The neat thing about this is you can always go back. Okay, you notice that in this particular form right here, I'm going to stop. These temperature probes are either in ethanol and methanol. The orange is in ethanol, that's the red, and the blue is in methanol, that's the second one right here. And right now it's equilibrating at some temperature, sitting in there. I'm letting the experiment run. And then what I'm going to do is I'm going to let it equilibrate, and then I'm going to remove them. And as I remove them, now the alcohol are evaporating off these filter papers, and look at the temperature drop. Okay, one is dropping faster than the other. And what I want to record in the data is, this is the initial temperature up here. You want to find the lowest temperature it reaches, because eventually it'll start going back up again. Okay, what I did was I just increased the time. So I could stop this experiment right here because I'm pretty much done. And what I did, of course, was I went back, took those things, put it back into the alcohol. And that's why it's gone up. It's gone to that temperature again. And then I'm going to do a second trial. And what I'm doing is I'm just looking at the temperature difference between the lowest and where I start. And here it goes again. Okay. So that's the data that you guys are recording for this experiment right here. I'm going to fast forward this. And here is a close-up. And this is actually Logger Pro, because the computer is actually recording this. And so what I did was I just took the computer, because you can run it as a movie, and I'm basically going to run it again. That way you guys can see in real time what the temperature drop is, and you have better resolution here. Okay, now you notice this is not moving, and the reason why this is not moving is because this is at the 150, 162. The data points is all the way on top. See how that's moving right there? Okay, that's because it's being collected, but your frame is between 150 and 162 in terms of this. That's why it's not shown. Anyway, that's the data for this particular experiment. It's also in the data that you can download. This is the second part. This is the acid-base property of household chemicals. Again, these are the different chemicals that you guys will be testing. These are the probes. And this is what it looks like. I have a bunch of test tubes here, 1 through 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. There's a missing bottle in here somewhere. 1, 2, 3, 4, 5, 6. Right here. Yeah, vinegars to the left that you don't see right here. Okay. Vinegar is all the way to the left. That's why it's not shown in this picture. But this is how you would set up this experiment if you were doing it. You have the solutions, and then you have litmus paper, and you have something called hydroion papers. Hydroion papers will change color depending on the pH. So what happens first? Well, we're just going to test each one of these individually. Well, before we do that, we calibrate the pH probe. We gotta calibrate it to pH 4 and pH 10. Okay, and pH 10, and then we test with pH 7. So that first part is just the calibration of the probe. Here you can see that, I apologize, that's sort of blurry, but that was 4 and that was 10. That's 10. Now we clean it and then we put in pH 7, make sure it's reading correctly, within plus or minus 0.1. Okay, so this one's actually pretty good. It's within 0.001. So once we do that, now we can test these solutions. And I put an inset of the hydroion paper. And the reason why I did that is because notice that I am touching a glass stirring rod to each of the solutions and then wetting the test paper. And when you wet it down, you need to make sure that you can do a reference. And colors may vary depending on your monitor, but they should all vary evenly. That's why I have that illustration of the different colors shown here. And now you could pretty much estimate just based on the litmus paper. Notice that there is red litmus and blue litmus, and then hydroion. So red litmus and blue litmus will tell you whether it's acidic or basic. And then the hydroion will tell you approximately what the pH is. So I go through all 7 solutions. And now just based on the color, you should give an estimate of what the pH are for each one of these. First one is vinegar, second one's ammonia, third one is lemon juice, fourth one is 7-Up, fifth one, well, you can see that. Now I'm putting in here some universal indicator. And the universal indicator legend is to the right. Okay. So I'm taking the whole solution now, I'm putting universal indicator. And again, it'll give you some sort of pH range. And I'm putting another drop or 2 to ammonia. And you guys will use the legend right here to the right to give an approximate pH of what that is. I'm going to fast forward. Okay. Now I'm going to take the pH probe and put it in each of these solutions. And then I'm going to read the pH of each of these solutions. And I'm going to do it in triplicate. You always want to do things in triplicate, because if one of them is an error, then you have another 2 to kind of see whether it's the error is correct or in the high side, low side, or just to confirm that it's correct. So that's the pH. Okay, you can see that whereas this experiment in the lab would probably take about, remember we're doing it over 2 days, so probably take about maybe 4 hours. This whole thing is done in 17 minutes. But you have a chance to go forward and backwards. Here's the pH of the different. This is series 1, series 2, series 3, series 4, 5, 6, 7. Okay, so these are the data set again doing it in triplicate. This is just doing it in fast forward. Wasn't really that quick in terms of doing this. Finally, the last one, and I'm going to stop there because I don't want to bore you guys to death. We'll talk about this next time. But Again, watch the video because it gives you an idea of how the data is collected. And here's the data right here. Okay, this is the data. This is the temperature, trial 1, trial 2, trial 3. This is the pH, 1, 2, and 3, 1, 2, and 3. These are the different trials. And then this is the last part, which we'll talk about next time. Today and Wednesday, we are going to be looking at activity number 4. Because we have remote instructions, you guys are actually not going to be using the vernier probes, but you guys do use the vernier probes if you're going to take organic at Miramar. And so you will see how to use the vernier probes. And I don't think, because we are at COVID for now, almost a year, and you guys probably started 152 about a year ago to 200 in the fall, and we were still remote. You actually have not physically touched any of these vernier apparatus. That's unfortunate because you really need to get your hands wet on handling chemicals and carrying out experiment. But we will try to do our best to let you see how these things are used. Okay, and so that's what these activities are for, is to make you guys more comfortable in using these vernier probes. The probes themselves, the hardware called Vernier, that's the company who makes them, and then the software is called Logger Pro. Okay, so what happens is you would be taking a laptop, you would open up Logger Pro. That's the program in the laptop that we have in the lab. And then you would connect these probes in order to collect data for the different experiment. The probes that you guys will be using in these 3 series are the stainless steel temperature probe. And because the computer has 2 USB ports, you can actually monitor 2 temperatures. You guys can also use the pH probe. And again, because there are 2 USB connections on the computers, you guys could do 2 pH probe. And then there's the SpectroVis probe. The SpectroVis probe measures the absorbance that are an indication of the color of the solution, which relates to the concentration of the solution. So part A is stainless steel temperature probe, part B is pH probe, and part C is the SpectroVis probe. Okay, so what we are going to be doing today is I'm going to remind you again, we talked about this on Wednesday, about the first activity, intermolecular forces of alcohol. And I've put in Canvas guidelines on how to do your PreLab, the details that I'm looking for. These are only worth 10 points, okay? So if you can keep to these formats and the talking points that I put, you guys should be able to get the 10 points easily. But it really is a way for me to give you some guidance before the first experiment on the details that I'm looking for and the format that I'm looking for in your write-up. So you want to use these 3 sub-experiments, activities, to practice that and then get feedback from me as far as what you can do better or what you're leaving out, things like that. Okay, so in today's discussion, we'll talk about intermolecular force. I'll talk to you guys about the guidelines that I give and give you more information on that, and then show you the data and how you guys are going to manipulate that data to get the information that is required. Okay, then I want to talk to you guys about the pH of household substances and show you how you can take the data and generate an Excel spreadsheet and then copy and paste that into your report. I'm just going to touch on those two. And then on Wednesday, I'll talk about the third part of this activity, the SpectroVis part. But I don't want to throw it all at you today because I want to spread it out. Go to modules. And in modules, you can always collapse these by clicking on these triangle. I think they're called chevrons. But we want to go here. I'm in the midst of grading everything that you've turned in, so please excuse me because there was a exam for my other class this past weekend. I was busy with that, but I'll get you guys your papers graded so you know where you stand in the course. So here's 22nd to the 28th. That's this week. And what we're going to be doing here is we're going to be taking a look at the activity. So I want to go back here and look at this part. 4A, activity intermolecular forces. And again, if you click on the first part, you'll see the background information. And the background information is basically a copy of what you find in your lab manual, at least a description. Okay. Of course, you guys can print this or just refer to it in your computer. You can collapse it here. This is the data, this is the PowerPoint, and this is the video. We went over the video last time. So let me go back. And again, go to the module page and then go to right here where it says activity 4, no Vernier intermolecular force. You guys, of course, asked me over the weekend where was the video for what we talked about last week. And it took me a while to render it just because I was busy with my other classes, but it's here now. Put it up over the weekend. Here is what I completed last night as far as guidance in your lab report. You want to use these in order to practice writing up the lab reports. Okay, so I'm going to go through each one of these so it's clear the details that I'm looking for. And you guys are at the beginning level of chemistry. I know you've already got 152 and 200, and hopefully they've trained you or given you the background in terms of writing a good report. And it's going to, the minute variations are going to depend on your instructor. Your instructor that taught 200, because I didn't teach you 200. Well, let's go back to 152. In 152, you guys had fill out a paper worksheet, okay? So you have an idea of what in the experiment was important. You kind of transfer that in a worksheet, and then you made sense of the data based on the worksheet. But it was basically giving you a guide as to what to write down, and then how to take the data and make sense of the data. So that was 152. 200, I think you had a greater flexibility in terms of, or you were given more freedom in terms of what to write down. Hopefully you did an experiment and your instructor told you that these are the requirements for a lab report. And in 200, at least if you were taking it in Miramar, you were supposed to write a lab report with an introduction that had a objective, background information, procedure, safety, answering any post-lab. That's not so different in 201. A data and observation, where you're recording your observation, writing a narrative of what's happening, and then you putting the data with the correct number of significant figures and the proper units in your lab report, in your lab notebook, okay? And then compiling those results and processing the data, doing the calculations, making sure that you are addressing the objective of the experiment, and then compiling the table of results, okay? From the table of results, you're able to pull out the significance of that experiment and then write a discussion on that, and then answer any post-lab questions. So hopefully you've got that from General Chemistry 1, okay? But like I said, it's going to vary slightly from instructor to instructor because they're going to have their own little tweaks in which they want you to write the report. And I have my little tweaks as well, okay? I went to, as an undergraduate, I was a chem major at San Diego State, and they had these notebooks that you fill in, and then you rip the pages and you submit them. I remember that was one semester. Another semester, we wrote in the composition book. And then at certain parts during the semester, we turn in our composition books, and then the TA would grade them, go through each one of these things, and then grade our reports. Okay. As a graduate student, I kept at Santa Barbara, I kept reports of what I was doing, what experiment I was going to be carrying out, and then writing a narrative of what I did and recording the data that I was able to obtain from the different instruments. Okay, and from the data and my observation, I was able to write up papers and get publications. When I went to Columbia, it was much more rigorous. Every Friday, my research director would have one-on-one, like we call them individual research reviews, but he would basically grab my notebook. And this was good because he needed to see the progress that I was doing for his group. Okay, I was a postdoc. I was maintaining his NMR instrument, and we had projects in order to get publications. But he was going over the ideas that he had and the projects that I was involved in. You don't just have one project. You're not just running one experiment. You've got multiple experiments that you're running at the same time. Okay, we would go in there about 9, 10 o'clock, and we won't leave the university, the research, till way past midnight. Okay, and some days. So that's life as a postdoc. But it trained me well in terms of what should be included in your lab reports. And through those experience, I've developed my own idea of how detailed your report should be, so that if someone were to look at your write-up in the future, they could basically follow along what you were doing and maybe mimic your experiment. That's the whole idea here, okay? And yeah, a lot of you are not going to be chemists, okay? You're not going to go after your PhD. Maybe you are going to go after your master's in biology. A lot of you are going to be doctors. A lot of you are in pre-med. Communicating with your audience is still key, whether you are a chemist doing research or in the health field. You have to write reports so that someone else after you can read and see what's going on. And so that's the whole idea here, is that you guys are getting training so that you can communicate. Yeah, chemistry is way different than medicine, but the fundamentals are still the same. You still got to make sure that you articulate what's going to happen, what data was obtained, your observations, and then making sense of that data. Those are still the elements in communicating, whether it be an experiment or monitoring a patient. So these are the guidelines that I'm providing so that in the future, whatever the situation is, you have an idea of how to communicate your findings to whoever's going to be reading, to the audience. Okay, so let's take a look at the pre-lab write-up and the background procedure. So I'm just going to click right here, and when I do that, the page should open. And in any, if you were writing, if you had a notebook, you always want to write your date, maybe the institution here, that's the course number, and then the title of the experiment. You always got to give at a glance what that person is looking at. We already talked about this in detail in maintaining a lab report, but here it's specific for this one. The objective. In 50 words or less, write the objective of this experiment, write what is to be investigated, the chemicals to be studied, and the experimental technique to be used. Okay, you guys are looking at intermolecular forces of different alcohols, and you guys are going to be monitoring the temperature change as different alcohols evaporate. So you want to put that in so many words in the objective. That's basically the essence of what these experiments are about. The background information, make sure you define intermolecular force. What exactly is intermolecular force? How is it related to the temperature change when something evaporates? You're looking at the heat of vaporization, okay? When something evaporates, it sort of removes that energy from whatever it comes from. So right here, I give you some talking points in your background information. I tell you to discuss intermolecular force. I tell you to discuss how physical properties like boiling point, heat of vaporization relates to intermolecular force. Then talk a little bit about the equipment you are using, okay? Vernier and temperature probe, stainless steel. Talk a little bit about how it's going to be set up. Elaborate more on the rate of evaporation and how it relates to intermolecular force, and then talk about the chemicals that you guys are going to be studying. There's only two chemicals that you are really studying. One is methanol, the second is ethanol. Propanol is in there because it gives you, the data gives you an idea of the delta T when propanol starts to evaporate. And then you're going to extrapolate what you think delta T will be for butanol. Ethanol has one carbon. Methanol has one carbon, CH3OH. Ethanol has two carbon. It's C2H5OH. Propanol has three carbons, butanol has four carbons. So the molar mass increases from one alcohol to the other, okay? That should be a clue in terms of how the intermolecular forces varies from one chemical to the other. You want to write that in your background because really that's what you're investigating. You're going to see if there's a correlation between the delta T that you are recording, the heat of evaporation, because that's what you're monitoring, and the molar mass or the intermolecular forces. After you give the background information here, you're going to write a little bit about the procedure. Again, remember I told you that I prefer a procedure that's a pictorial flowchart. So here I'm trying to kind of like ease you in, maybe write an outline, and after each outline, a statement, draw an icon of what's going on, okay? The data to be collected, then the two data that you guys are really collecting is the different temperature change for methanol and ethanol. And you're actually doing three trials. So here you got delta T1, delta T2, delta T3 is right here. And you're doing three trials. In chemistry, we always try to do three trials when we can. Okay, why is three trials important? Because you need to do some sort of statistics. And if you have two data, you can't do any statistics. Okay, two data, you can get an average, but you can't do any standard deviation. Okay, when you have three data points, that's the minimum number of trials you need. One will give you a reading. The second might be higher or lower than that. But if it's really low, then the third one really gives you information as to where to bias your readings. It might be closer to the first, might be closer to the second, or it might be in between. But then what you can do is take an average, and then you can look at those three data points that you have and compare it to the average. You can't do that with two data points. You can do it with three, but not two. What happens is that you can take the average of the three, look at the first one, see how far that deviates from the average. Look at the second one, see how far that deviates from the average, and look at the third and see how far that deviates from the average. That's called the standard deviation, more or less. Okay, and why is the standard deviation important? Because it tells you the degree of precision that you have. If your standard deviation is small, it means that each of your measurements are close to each other. If your standard deviation is large, it means that you're just all over the place. That's why we do three trials, a minimum of three trials. If you really can't help it and you only have two trials is better than one, but you can't do any statistics with two trials. You can get the average at the most. Okay. In the real world, we try to do 3 or more. Okay. But here we're trying to, and what you will see is I do a minimum of 3 trials in each one of these procedures so that we can take an average and calculate a standard deviation. Okay, so here's the procedure. You want to make sure that you write down in the, I'm trying to ease you in again, but practice drawing pictures. Okay, practice drawing pictures and try to be neat about it. Try to be neat about it. Here's a safety. What you can do is you can just Google SDS, safety data sheet, and then the chemical. And what you will get is something that looks like this. Okay, and what I'm going to do is I'm going to Google SDS, safety data sheet, and then I'm going to say ethanol. And you'll get a hit. Okay, you'll get a hit like this right here, or this right here. Usually the first one's good enough. And it's going to be very lengthy because they're going to give you as much information on that particular chemical. What you want to do is probably just take a screenshot of the first page, because the first page really tells you a lot of information about it. That's really what I'm looking for. And then paste it in your report. Okay, and then provide the link for that. But that's basically it in terms of the safety. And then don't forget to write in your own words the chemical that's being used and the quantity that's going to be used in this experiment, and then how we are going to dispose of the waste. Yes, it's sort of funny how you should write that when everything's virtual, but hey, amuse me, because when things get back to normal, hopefully this fall, you guys are going to have to know how to handle these chemicals and the proper disposal technique. Okay, you guys are all in Chem 201. You have a lot of science ahead of you. Okay, you still have a lot of lab ahead of you. So even though we're in a virtual world, try and get what you can from these videos so that when it comes to hands-on, come this fall or next spring, you guys already have an idea of how to handle these chemicals and how to dispose of it properly. Okay, so that's your safety data sheet right there. And then answer any pre-lab questions. I don't think there are any pre-lab questions for this activity, but if there were in like experiment number 1, you want to put it the very last section. This is the format that I want. Okay, you want to write the objective, a heading, I mean, objective, background information, the procedure, pictorial form, the sample data table. That notice it's only a sample data table with what is going to be written in a data table. It's not the whole data table because you're going to recreate it again in your data and observations. This allows me to know that you actually know what data is important in this experiment. So that's your pre-lab. Okay, that's your pre-lab. It's not going to be due until Wednesday. And then I'll show you how to submit that. This is your data and observation. When you actually watch the video, this is what you guys are going to do. Again, put a heading because this is a different section, title of the experiment, and then your observation. Write a description of how the stainless steel temperature probe is set up with the filter paper, how it is connected to the computer, describe what program is launched in Logger Pro, and the parameters used. Okay, write a narrative of what's going on during the procedure. That is, you're connecting this, you're allowing the temperature probe with the filter paper to be submerged into the different alcohol that's in a test tube. And then you start the program, and then you allow the program to run about a minute so that the temperature equilibrates. And then you simultaneously remove both temperature probes, and then you set it at the edge of a desk, and you allow the alcohol to evaporate from the filter paper. The computer's still running, still monitoring the temperature. And what you should see is the temperature drop. Okay. And then after some time, you should denote the time, it starts to go up, it starts to warm up. Okay. So these are the type of information that you guys are going to be seeing in the video. And then this is what's going to be filled out during the experiment. Methanol, you guys need to know what the molecular weight is. Ethanol, molecular weight, you should also figure it out for propanol and butanol. But the data you are collecting is delta T1, initial, 1, 2, 3, final, 1, 2, 3, and then the delta, 1, 2, 3, and then you want to take the average. This is the first trial, second trial, third trial, and take the average. And you want to do it for methanol and ethanol. Here, I tell you what the delta T for propanol is. It's actually 5.1. That's the delta from the highest point to the lowest point. And from these three data points, from methanol, ethanol, and propanol, you're going to graph and then extrapolate what it would be for butanol. Okay. And in this particular case, the delta T is the y-axis, and the molar mass will be the x-axis. Okay, molar mass will be the x-axis, delta T will be the y-axis, and that's what you're graphing as far as what the description says. Then, based on what you know the molar mass of butanol happens to be, you're going to predict or extrapolate what the delta T for butanol should be. So that's your data. You're just writing in data in here that you are collecting. Okay. So let's get out of here, and then I'll show you the post-lab write-up for this part. Again, we go over here to this part right here. Click on that, and this is the post-lab write-up. Click on that, and this is the guidance. So again, a header, data, course number, title of experiment, processing the data. That's the first thing that you guys are going to be doing after collecting the data, after your data and observation. If we were doing this in lab, okay, the pre-lab would be due before you walk into class. You would have read the experiment, you would have written out the objective, the background information, the procedure. So before you walk into lab, this would have been turned in, the pre-lab. Then while you are in lab, okay, as soon as you go in, we can start the experiment, because I usually give you a pre-lab before that experiment is scheduled. You just go in and you are working alone. You are doing the experiment, you're writing your observations in your notebook, or typing it in the computer under lab archives, or just recording it, but not on scratch pieces of paper, okay, some sort of document. And then you're writing the data, you're compiling the data. Once the experiment's over, you're cleaning up, okay, making sure everything's back to its original condition, and you're done, okay? You're done with the experiment. You can leave, basically. What you should do, however, before you leave is turn in the data that you've collected. Then a week and a half later, or between when it's due and when you end this experiment, you will write up the report. So this is what you would have done. You would have looked at the data, you would have processed and do the calculation of the data. Here, we give you some guidance of what you needed to do. You need to calculate delta T 1, 2, and 3, which you could have done already in your data and observation. Calculate the average, and you could actually calculate a standard deviation as well, okay? And then graph the results. Here is the graph. I told you this is delta T. It's on the y-axis. This is molar mass. It's on the x-axis, and you're going to be plotting these. Of course, you won't have the data for butanol, but then you can extrapolate from the first data point, then predict what delta T for butanol is. From that, okay, you guys want to make sure you put this in an Excel file, and then do a copy of the screenshot or print it. It's probably best to do a copy of the screenshot since everything's going to be digital. Just paste it in here in your processing and data calculation. Just paste it in there with the molar mass and delta T table. Okay, and it's the average delta T. not the individual delta T1, delta T2, delta T3. It's the average of methanol, average of ethanol, and then whatever's given for propanol. Okay, so that's processing the data. And then I always want a summary of results or the table of results. And this is what I'm looking for this particular experiment. Okay, the chemical name that you are investigating: methanol, ethanol, propanol, butanol. Why is propanol and butanol in there even though you haven't used those chemicals? Because you're going to need that information as you make the interpretation of your results. Okay, so put it in this table of results. The chemical formula. The chemical formula allows you to see how big these, well, the chemical formula of these chemicals, the chemical structure allows you to see how big these chemicals are. And that should relate to its intermolecular force. Remember, all of these have OH groups, so they all have hydrogen bonding. Okay, all of these have electrons. Any chemical that you can isolate will have electrons. So they all have London dispersion force. Since they have hydrogen bonding, they're all polar. But what makes them different is their London dispersion force, because some are bulkier than others. Okay, so that's what I'm going to say about the chemical structure and intermolecular force. The molar mass is going to be important. And then the type of intermolecular force each chemical possess. I already told you that. And then whether the chemical is polar or non-polar. You guys should know. All alcohols are going to be polar. Rank the intermolecular forces based on the chemical: methanol, ethanol, butanol, propanol. Rank it, which is the lowest, which is the highest. Again, why am I asking you this, even though it's pretty obvious? I'm asking you this because when you write your discussion, you're going to use that information to give me a coherent discussion of how the delta T relates to the intermolecular force. And when you have this in your table, you can refer to it. You're not just searching on the top of your head or pulling something from midair. Everything's there. You can say, if you take a look at my table of results, these are the intermolecular forces, these are the molar mass. You can refer to it in your discussion. It makes for better concrete discussion when you have data to support what you're talking about. And that's what the table of results provide. Okay, and then here are your talking points in your discussion. Okay, these are the talking points, and then these are also talking points as related in the lab manual. So you want to make sure that you discuss each and every point here so that you're coherent. Remember what I said when we're talking about lab notebooks. Look at your objective. Your objective is the main thesis of this experiment. You're kind of like a trial lawyer. A trial lawyer has an opening statement, basically what they're trying to do. As a scientist, you have an objective for an experiment, and everything you do is going to support that objective. The data that you collect, the background information you provide, the table of results you have, and your discussion all supports that. So your discussion should go back to the data that you have in supporting the objective of this experiment. Okay, that's why you have these things outlined the way it. That's why you have the format. Okay, that I provide. The conclusion is just that it's not supposed to offer anything new. Okay, it better not offer anything new, otherwise it would have been in discussion. It basically tells me what the objective of the experiment is and the results that you got to validate that objective or not to validate that objective if something went wrong. It's going to be short, a little bit longer than the objective, because it's telling me what you're trying to find, what data you got, and the results if it confirms that data. And then answer to any pre-lab, post-lab questions. It should be post-lab. Okay. And in this case, I don't think there are any post-lab in any of these. But again, you want to practice these right here, because if you make a mistake, it's not going to hurt you one way or the other. In fact, you want me to give you some guidance as to the details that you are writing. That way, when it comes to the real experiment, and especially experiment number 6, which is your evaluative report, okay, your evaluative report, that's your SLO for this class. In this class, we expect you to write reports that are pristine, that are top-notch, that will carry you on to organic chemistry and your upper division courses. So these right here, this activity gives you practice in how to craft your work and make it up to the level that I'm looking for. Okay, so that is what you want to do. And when you write this up, okay, again, you'll find it in the module. You could type it up in Word, or you can type it up in your document. But when you submit it, you're going to have to go through the text box in Canvas. So type it up in Word, get all the information in there, and then when you go to here, okay, 4A, click, I'll do a student view. Click right here, submit. And when you submit this, you're going to put one, this first part is your PreLab write-up. It will be background and procedures. Okay, and then just kind of start objective. Or if you've already got it in Microsoft Word, just paste it right here. But this is where you guys are going to be putting it. Don't give me a document where I have to open up. Actually have it in here like you were typing it up, like you were in Lab Archives, because that's how Lab Archives work. Okay, everything should be in here in terms of I can just open it up and read through it. So you're going to write your PreLab, and then still on the same page, you guys are going to do your data and observation. Okay, now suppose you're not done. Suppose okay, I'm going to get started and get go ahead and submit it. And then what you can do is, okay, I need to complete this. Go back to, I guess, submission details. And in submission details, you can open up where you left off. Okay. And then start adding to whatever you wrote. So within this one space in Canvas, you can put the PreLab with all the information. You can put your data and observation with all the information, and you can put your post-lab write-up with all the information. Now, that's not how it usually works in an experiment. In a regular experiment, you're going to have 3 different sections. But for now, I just want everything in one page, in one submission. Okay, so that's where you would do this, and then you could save it. And then if you need to return back to it, you can do a resubmit as well. Okay, you can do a resubmit as well here. And then I can do submission details. Remember, it's submission details if you want to edit this thing again. And here it is. And then save, and then resubmit. So whatever changes, you always want to resubmit. And then when the deadline comes due, it's going to just close it and you won't have access to it anymore. So that's the data for the intermolecular force. And remember that the data sheet is right here. This is for trial 1. And sorry, this is, yeah, for trial 1. This is the time. This is methanol. This is ethanol. This is trial 2. This is ethanol. This is methanol. And this is trial 3. And the question really is, if you look at these right here, let me see if I have that data. Okay, because I would prefer you guys to make sure that you have this in an Excel format. So I think we are here. We are here, and here it is, I believe, graph. It's pH. So let me open up Excel. Okay. I think you can copy and paste these things in Excel. So let me take a look at this. Let's see, why is Excel taking so long? Make sure that program is launching. Okay. If I haven't opened up a program initially, then it sort of does this. This is not what I want. This is the wrong data set. Activity unknown, activity 4. Let's see what this is here. Intermolecular force. So it's not it either. Remember, these data, I forgot what we were doing. This data just tells you the temperature. Let me blow this up. This is the temperature that you have for methanol. It starts at 20.06. And if you see the video, I actually show you the video. And so you're starting at about 20.0, maybe 0.6 is your high point. And then as soon as it's removed from the alcohol, it starts to drop. So if you have your initial temperature at 20.06, for ethanol, it looks like it's 19. Again, it doesn't matter what the temperatures are, you're only looking at the difference. So here you're looking at probably 19.60 or 19.59. And then you're watching the temperature drop. And here you can see it drops all the way to about 6.30 is the lowest temperature that I can see. So that's your two difference. That's your delta T right there. 6.30 all the way to 20.06. That's delta T. For ethanol, again, you're looking at 19.6, and then you look for the lowest temperature dip, and that would be at about 13.3, 13.26, 12.9593. 12.93 seems to be your lowest. Okay. I think that's the lowest as far as I can see. So that's your delta T for ethanol. So that's really what you are looking for. It doesn't really matter the time. The time just kind of shows you, because that's what's being graphed. That's the graph that's being generated, time versus temperature. So that basically is it, but you're looking at delta T here. So you can calculate the temperature difference for trial 1, trial 2, and trial 3. And then you're going to record that. So that's how you would work this. And then, of course, you just write up your report. That's what, put this into the data sheet. So that would be experiment number 4A. Okay, 4A. Of course, you can, if you go back to the original, you can watch the video. And the video shows you, let me get out of student view, all three sections: the intermolecular force of alcohol, the pH of substances, and the absorbance of different concentrations of cobalt chloride. So where do you find that? You find it right here in terms of the video. Right here is the video. Okay, just click on that. You can expand it if you want. You can fast forward this to where you want this thing to show. Okay. I apologize for the fact that the resolution on this is actually the calibration of the pH probe. You guys are going to have to see that. Here are the different temperatures. Notice the time is one continuous time chart. And that's because all you're looking is delta T. So if there's no questions on that, let me move on to the pH experiment. And then I'll show you how to take the data there and generate a column chart. So here we are in modules. Go to this part right here. It's the only thing that you should be working on. And I already given you the guidance. Okay. This part right here, the pH and the concentration of cobalt chloride, you guys can get started on that on Wednesday. Spend most of your time the next couple of days trying to do this part based on the guidance that I give you. This part right here, you can do Wednesday and you can turn it in up to next Monday, I believe. Okay. I think if I click here, it'll say March 1st. Let me get out of this view real quick. Leave student view. Yeah, it's March 1st until date. Okay. The due date is the 26th of February, which would be this Friday. If you want to get bonus points, the final date is next Monday for this report. Now, let me just mention before we all leave that you write in one space the report for intermolecular forces of alcohol. You write in one space the pH of acid base, but you write in 3 spaces in its different parts, just like you would do a different experiment. The 3 sections of cobalt chloride. The PreLab would be here. You write it, okay, by clicking on submit, and that will give you access to the text table. And you want to just put your PreLab here, and then you want to write in one space, in a different space, the data and observations. That's this right here. And then you want to write in a different space the post-lab. And that's the way the write-ups will be in your regular experiment. You have 3 spaces. I'll give you 3 links to put the different sections. And they'll have different due dates. They'll have different due dates. Just like you see right here, there's the PreLab, there's the data and observations, and there's the post-lab. The first 2, you put it in one space. But for this one, I want you to get used to writing the report as would be required when we do our first experiment. So